Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 1 in a session February-March 2018, Paper 1-2. So let's start with the first question. Question number 1, a curve passes through the points 4 and negative 6 and has an equation for which dy by dx equals to this. Find the equation of the curve. Okay, so we have given the derivative, we have to find the value of y. The equation of curve is basically y we have to calculate. Alright, so we have the derivative which is given dy over dx, which is equals to x to the power minus 1 by 2 and negative 3. Alright, to get the value of y, the equation of curve, we have to integrate on both sides. Alright, so let me integrate on both sides. Integrate on both sides. Alright, let me take integration of dy over dx with respect to dx equals to integration x power minus 1 by 2 dx minus 3 is outside integration of dx. Alright, so from here the derivative and this integral is cancelled and dx is cancelled with dx, and we are left with y, and the integration of x to the power n has a formula. Let me write this down. Integration of x to the power n dx, this is equals to x to the power n plus 1 over n plus 1 plus some constant of integration. Alright, so we have x to the power minus 1 by 2 plus 1 over minus 1 by 2 plus 1 negative 3, the integration of 1, we have just constant is 1 over here, so its integration is x, and plus some constant of integration is this integral has a constant of integration and this has a constant of integration, and together there is just one constant of integration, that is c. Alright, so let me simplify. Minus 1 by 2 plus 1 is 1 by 2. Minus 1 by 2 plus 1, this is 1 by 2, so y, this is x to the power 1 by 2 over 1 by 2 minus 3x and plus c. Okay, further simplification, y equals to, this is going to be 2 and square root of x. Okay, x to the power 1 by 2 is square root of x, and 1 by 2 it's reciprocal, we have to shift to the numerator which is 2, and minus 3x plus c. That is the equation of the curve, but we have to find the value of c. So for which for this we have given the points that the curve passes through the point 4 minus 6. So this is equation of curve. If the curve passes through the point 4 minus 6, it means it satisfies this equation if it is passing through the points. So let me plug the points. Y is negative 6, this is equals to 2 square root of 4 minus 3, x is again 4 plus c. Let me solve the constant of integration. So we have negative 6, this is 2 and this is equals to 2, and minus 4 times 3 would be 12 and plus c. So minus 6 equals to 4 minus 12 plus c. Alright, so minus 6, so from 4 take away 12 is negative 8. Yes, it's negative 8 plus some constant of integration. Now minus 6 and plus 8, shifting the 8 on the other side, it becomes positive. This is equals to c. From 8 take away 6, this is just 2, so 2 is the value of constant of integration. Alright, so now the equation of curve, we can say equation of the curve is going to be, just plug the value of c and we will get this equation of curve, which is y equals to 2 square root of x minus 3x and plus 2. The constant of integration is 2. So that is the equation of curve. Question number 2, part 1. Find the coefficients of x square and x cube in the expansion of 1 minus 2x to the power 7. Alright, so we have to find the coefficients of x square and x cube. So let me apply open the binomial expansion. So 1 minus 2x, its exponent is 7. So that is equals to 1 exponent 7 plus 7c1, 1 exponent is 6, and minus 2x, its exponent is 1 plus 4, sorry, not 4, it's 7c2. 1 exponent is 5 and minus 2x, its exponent is 2 plus, and 7c3, 1 exponent is 4 and minus 2x, its exponent is cube, plus 1. Okay, so here you can see the first term, its exponents are decreasing from the power n, that is 7. So 7, 6, 5, 4 and so on. And the second term minus 2x, its exponents are increasing. So here minus 2x power is just 0, and here 1, here 2 and here 3. Okay, so we have to find the coefficients of x square and x cube. So we got this is a coefficient, this is this term we will get x square and this term we will get x cube, and this is a constant term and this is the x term, right? So we are just dealing with the x square and the x term. Okay, so coefficient of x square first. Okay, this term we will get x square. So coefficient of x square is 7c2, 1 to the power 5 minus 2 to the power 2. So x square, I'm not writing x square over here because that is the coefficient of x square. All right. Okay, so 7c2 is 21. 1 to the power 5 is 1 and minus 2 to the power 2 would be 4. So 21 times 4, this is equals to 84. So we have 84 is the coefficient of x square. Now let me work on the coefficient of x cube. So here you will get the term of x cube because x to the power 3 would be x cube. So what is the coefficient of x cube, which is 7c3, 1 to the power 4 and minus 2 to the power of 3. I'm not writing x to the power 3 because that is the coefficient I'm dealing with. Again, we have 7c3, 35. 1 to the power 4 is just 1 and minus 2 cube is minus 8. Minus 2, its cube is minus 8, right? Minus 8 times 35, that is minus 280. So minus 280. So we can say the coefficient of x square is 84 and the coefficient of x cube is negative 280. Now for the second part, hence find the coefficient of x cube in the expansion of this. Okay, so we have 2 plus 5x. This is going to multiply with the expansion of 1 minus 2x to the power 7. Okay, so here is the expansion. I opened 1, 2, 3, 4 terms. So the first term 1 to the power 7 is 1. All right. Now for the second term, let me calculate the second term. 7c1, which is 7, times by 1 to the power 6 is 1 and times by negative 2, that is equals to minus 14x. That is the second term, minus 14x. And the third term is x square term, which it has a coefficient of 84, x square, and the cube term is minus 280 is the coefficient of x cube, and plus up to so on. All right, we have to find the coefficient of x cube. All right, so when we multiply this 2 is going to multiply with 1 minus 14x plus 84 x square minus 280 x cube and so on, and plus 5x is also going to multiply with the bracket 1 minus 14x plus 84x x square, yes, and minus up to so on. All right, so now we have to find the coefficient of x cube, right? So keep in mind, so I'm just working with x cubes, not with the rest of the terms. 2 is multiplying with 1, it's a constant term. This is going to be the x term, this is x square term, this is going to be x cube term. So the x cube term from here is 2 into minus 280 x cube. All right, now this is the x term, 5x times 1 x term we will get here, times with negative 14 x times x square term, and this is x cube term, which is 5x is multiplying with 84x square. All right, 2 times 280, 560. minus 560 x cube, 5 times 84, which is 420 x cube. So 420 minus 560, which is equals to 140 x cube. So we can say the coefficient of x cube is minus 140. Now question number 3, on a certain day the height of a young bamboo plant was found to be 40 centimeter. This is on a certain day. After exactly one day, its height was found to be 41.2 centimeter. Two different models are used to predict its height exactly 60 days after it was first measured. After it was first measured, the first measurement is basically 41.2. That is the first measurement, because this is 40 centimeter is the initial one. After exactly one day, this is the first measurement, which is 41.2, and we have to find its height exactly 60 days after it was first measured. But now for model A, assumes that the daily amount of growth continues, daily amount of growth 40 centimeter, 41.2 centimeter. This is the daily amount of growth that continues to be constant at the amount found for the first day. All right, so it is constant, it is increasing in a constant amount. So it means this is an arithmetic progression. For model A is arithmetic progression because it is increasing at a constant rate. It means the difference between the term is constant. All right, model B assumes that the daily percentage rate of growth, the initial was 40 and then we have 41.2. So daily percentage rate of growth, it continues to be constant at the percentage rate of growth found for the first day. So we have a percentage rate of growth, so it means we have a geometric progression. Now for part 1, use the model A, find the predicted height in centimeter of the bamboo plant exactly 60 days after it was first measured. Okay, I'm repeating it. It was first measured. So first measurement, exactly one day, the first measurement is 41.2, not 40. 40 is on a certain day they measured the height of that plant. All right, so for arithmetic progression, we have to use the formula A n is equals to A plus n minus 1 into D. Okay, so we have to find the height, an, it means a60 we have to calculate. A is the first term, which is 41.2, n would be 60 minus 1, and D is the common difference. All right, so here we have 40 and then we have 41.2. So how can we find out the difference? We can do 41.2 minus 40, that would be the D. So let me calculate it. We have 41.2 minus 40, which is 1.2. Yes, D is 1.2. The common difference between the term is 1.2 because it continued to be constant. So D is equals to 1.2. All right. So now let me calculate it. We have the first term 41.2 plus n minus 1, which is 59 into 1.2. All right. 59 times 1.2 and we have 41.2 add with answer, which is 112. So this is 112 centimeter. This is the height of the bamboo plant exactly 60 days after it was first measured using the model A. All right. Now for the second part, using model B, find the predicted height in centimeter of the bamboo plant exactly 60 days after it was first measured. So as we know that the model B is geometric progression, and for geometric progression we have a formula an equals to A into r to the power n minus 1. Right, a60 we have to calculate again. A is the first term, so again I'm taking the not 40 is not the first term. The first term is 41.2. Why? Because after exactly one day, this is the measurement. This is a measurement on any certain day. All right, so the first measurement we have is 41.2. R is the we have to find the common ratio. So to calculate the value of R, we have to divide the second term, which is 41.2 over 40. This is R. 41.2 divided by 40. This is equals to 1.03. So 1.03, n is 60 and minus 1. All right, 1.03 to the power 59 and times by 41.2. This is 235.6. 235.6, or we can round it to 236 centimeter. Okay, this was an easy question, but the main concept in this question is, as you can see from model A and model B, we can easily predict that A is a arithmetic progression because it is increasing at a constant rate, means the difference between the terms is same, and B is easily we can get from the percentage rate of growth with the geometric progression. But the main concept is which is the first term. So keep in mind the first term is 41.2, not 40 over here, because most of the students get confused with the first term and they will take the first term as a 40, but 40 is not the first term because they are saying after exactly one day the height is 41.2, and we have to find the height of the plant exactly 60 days after it was first measured, and it was first measured, the first measurement was after exactly one day. This was the first measurement. All right, I hope this makes sense now. Question number 4. A straight line cuts the positive x-axis at A. If it cuts the x-axis, it means there is an x coordinate, but the y coordinate should be 0, and the positive y-axis at B, which is 0, 2. Angle BAO we have given, which is pi by 6 radians, where O is the origin. Origin means 0, 0. All right, let me draw this situation to make this understandable. Okay, let me draw the x and the y-axis, and we are dealing with the positive x-axis and the positive y-axis we have given in the question. So we draw the straight line. All right, and the straight line cuts the positive x-axis at point A. So A has an x coordinate and y is 0, and a positive y-axis at point B, which is 0 and 2. So it means, and O is the origin. This is O, and origin is 0, 0. All right, so means this height is from 0 to 2, so this height is just 2. All right, and the angle BAO, this angle is pi by 6 radians. Number 1, find the exact value of x coordinate of A. What is the exact value of x coordinate of A? This distance we have to calculate. So as you can see, this distance is from 0 to 2 is just 0. This is from 0 to x. So we can say this is x, which we have to calculate. Okay, so this is a right angle triangle. We can use the trigonometric ratios over here. So we have this angle, front side is opposite and this is the adjacent. So adjacent we have to calculate, we have the opposite, so we can use a ratio for tangent. So we can say tan of theta, which is pi by 6, this is equals to opposite is 2 and adjacent is x. Okay, tan pi by 6, it should be in radians. Okay, my calculator is now in radians. We have tangent of pi by 6. This is square root of 3 over 3. Square root of 3 divided by 3, and this is equals to 2 over x. All right, now we have to solve for x. So cross multiplication, we have x should be equals to 2. X is multiplying with square root, okay, and times by 3 over square root of 3. All right, so I cross multiplied x shifting on the left side and this term shifting on the right with the reciprocal 3 over square root of 3. 2 times 3, that would be 6 over square root of 3. Okay, so 6 divide root 3, this is 2 root 3. This answer is 2 root 3. All right, so we can say the x coordinate of A is 2 root 3. All right. Now moving to the second part of 4, find the equation of the perpendicular bisector of AB, giving your answer in the form of y equals to mx plus c, where m is given exactly and c is an integer. C should be an integer and m you have to give exactly. All right. So we have A and B. We have to find its perpendicular bisector. So for the perpendicular bisector of AB, which things we need? Okay. We need the slope and we need the midpoint. All right. So let me write down the coordinates. Coordinates of A is 2 root 3 and 0. And the coordinates of B are 0 and 2. So first we have to find the slope of AB and then we have to find the slope of perpendicular bisector of AB. So slope of AB, this should be equals to y2 minus y1 over x2 minus x1. So this is x1 y1, this is x2 y2. y2 minus y1, which is 2 minus 0. x2 minus x1 is 0 minus 2 root 3. This is equals to 2 and this is minus 2 over root 3. So this should be equals to minus 1 over root 3 because 2 is cancelled with 2. We are just left with minus 1 over root 3. Okay. Now we need the slope. We don't need the slope of AB. We need the slope of perpendicular bisector of AB. So we can say the slope of perpendicular bisector of AB is negative reciprocal. So negative, if we can take negative of something, so negative of negative is positive and the reciprocal of 1 over root 3 is just root 3. That is the slope of perpendicular bisector of AB. Okay, so the second thing we need is the midpoint of AB. Midpoint of AB. All right, midpoint has a formula adding the x components x1 plus x2 divided by 2 and adding the y components y1 plus y2 and divided by 2. You will get the midpoint. All right, so the x components are 2 root 3 and 0. So we have 2 root 3 over 2. Adding with 0 stays the same. 0 and 2 are the y components, so 2 dividing by 2. So the midpoint is root 3 and 1. This is the midpoint. Now let me write down the equation of perpendicular bisector. Equation of perpendicular bisector of AB. Okay, now that equation is, if we can take the, you can use the equation y equals to mx plus c, or you can use the equation, you have a point and the slope. So let me use y minus y naught equals to m into x minus x naught, and we have to convert this into y equals to mx plus c form. Okay, now what is x naught and y naught? This is x naught and this is y naught, the midpoint, and m is, that would be the slope. So we can say y minus y naught is 1, m is the slope, which is root 3, and x minus x naught is root 3. So let me simplify this side. So y minus 1 is as it is, which is root 3 times x minus root 3 times root 3. So root 3 times root 3 is basically 3. Let me show you guys. Root 3 times by root 3, which is just 3. All right. So y minus 1, this is equals to root 3x and minus 3. So y should be equals to root 3x minus 3, and shifting the 1 on the other side, it becomes plus 1. So y should be equals to root 3x and minus 2. That is the equation of perpendicular bisector of AB in the form of y equals to mx plus c. Okay, m is given exactly. M is in exact form. We have to write down m in exactly, and c should be an integer. Minus 2 is an integer. Question number 5, part A. Express the equation as a quadratic equation in tangent of x, and hence solve the equation for x should be between 0 to pi. All right. So make a quadratic equation in tangent of x. So cross multiplication is the first step. 5 plus 2 tangent of x this should be equals to 1 plus tan x and its product with this cross multiplied, 3 plus 2 tan x. Okay, 5 plus 2 tan x. Okay, so first we are multiplying with 1, so it is 3 plus 2 tan x. It stays the same. When we are multiplying with 1, the bracket stays the same. Now multiplying with tan, so 3 with tan is 3 tan x, and 2 tan times would be tan square of x. This is a quadratic equation in tan x, right? Now let me arrange that quadratic equation, like shifting all the terms to the right. Let's say 0 over here, we have 3, this is 2 and this is 3, and both have tan x. These are the coefficients of tan x, so 2 plus 3 would be 5, so we can take 5 tan x plus 2 tan square of x. So I shifted this 5, it becomes minus 5, and shifting this 2 tan x is minus 2 tan x. 0 should be equals to 2 tan square of x. Arranging the terms, first the square term, the tan terms are 5, take away 2 would be 3 tan x, and 3 minus 5, this is negative of 2. This is a quadratic equation in tangent, which is 2 tan square of x plus 3 tan x minus 2. Now we have to solve this equation from x should be 0 to pi. Okay, so to solve this equation, apply the quadratic formula, obviously. Okay, from quadratic formula we can say tan x is equals to minus b is 3 plus minus square root, the b is square is 3 square, minus 4 times a times c, and divided by 2 times of a, which is equals to 2, right? So this is the a, this is my b, and this is my c. All right. Okay, now let me simplify this. Tan x is equals to negative of 3 plus minus square root of 3 square would be 9, and plus negative times negative is positive, 4 times 2 times 2, that would be 16. 16 plus 9 is 25, and root of 25 is 5. Dividing by 4. Alright, so we have tan x is equals to minus 3 plus minus 5 divided by 4. Now we have two solutions over here. We can say tan x is equals to minus 3 plus 5 by 4, or tan x is equals to minus 3 minus 5 by 4. Minus 3 and plus 5 is 2. 2 by 4. 2 by 4 is 1 by 2. Here we have 1 by 2. This is tangent of x. And the other root, we are getting minus 3 minus 5 divided by 4 is minus 2. So tan x equals to negative of 2. So what is x? X is equals to tangent inverse of half. So you can see the domain is in radians, 0 to pi. X values should lies between 0 to pi, so my calculator should be in radians, right? So tangent inverse of half is going to be 0.4636. X is equals to 0.4636. 0.46 and 36, I round this 3 to 4. This is my x. And from this equation we can see tangent of x is 1 by 2. Here tangent is positive, so we have to check tangent is positive in which coordinate. Let me draw this over here. In which quadrant tangent is positive and in which it is negative. C, A, S and T, the cast rule I'm using. C means cos positive, all positive, sine, and tangent is positive. And this rule is we have to take x, and here we have to take pi minus x, here we have pi plus x, and here we have 2 pi minus x. All right. So tangent is positive in the first quadrant, tangent is positive, and in the third quadrant, tangent is positive. All right. So this is a value of x in the first quadrant, which is 0.464. Now for the third, this is for the first quadrant. Now what is for the third quadrant? Now for the third quadrant, we have to use the operation pi plus x, means pi plus this value. Plus we have a pi, and this value is more than our domain, which is between 0 to pi. The range we have given, the answers of x should lies between 0 to pi. So when we add something in pi, it means it is more. So here we have x is 3.61, which does not belongs to the range, the given range. So this value belongs to the range. Now this is the second solution. Now the second equation, it says tangent of x equals to negative of 2. What does this mean? It means that in which quadrant tangent is negative. So tangent is negative in the second and in the fourth quadrant. All right. So let me solve this equation. We can say x should be equals to tangent inverse of 2. We have to solve the positive always. Tangent inverse of 2, this is equals to 1.107. All right. Now we have to check that in the second and fourth quadrant. Now for the second quadrant, we have what is the second quadrant is pi minus this x. So we can say pi minus answer. This is equals to 2.034. And for the fourth quadrant, tangent is also negative in the fourth quadrant. Fourth quadrant operation is 2 pi minus x. 2 pi minus x is 1.107. This is 2 pi minus x, 5.176, and this value again does not belongs to the range. My range is between 0 to pi, and pi is basically, you can say, 3.16. So my domain is between, as you can see, in the question we have given the x value should lies between 0 and pi, which is between 3.1416. All right. So between 0 to 3 we can say. So as you can see, this value is 0 to 3, this is more than 3, this is between 0 to 3, this is more than 3. So we can say the values of x which satisfy the given range is x is equals to 0.464, and we have x is equals to 2.034. These belongs to 0 is less than equals to x is less than equals to pi. These are the two solutions. Now for part B, the diagram shows part of the graph of y equals to k sine theta plus alpha, where k and alpha are constants and alpha is between 0 to 180 degree. All right. Find the value of alpha and the value of k. Okay. So this is a sinusoidal function. We have to, k is basically the amplitude that we have to calculate, and alpha is the phase shift, the starting point of the sinusoidal function. So what is the base function of this? The base function is, we can say, the base or the parent function is y equals to sine x. That is my base function. So let me draw the graph of sine x between 0 to 180. Okay, so let me start with 0. Okay, we have, if I can take this in centimeters. All right. So where is 150? Okay. Or between 0 to 180 alpha should lie. So if I can say at x is equals to 0, at x is equals to 90 degrees, 0 degrees, 90 degrees, and x is equals to 180 degrees. 0, 90 and 180, we are just solving it. So for 0, sine 0, we have y equals to 0. And what is sine 90? Sine 90 is 1. Okay, my calculator is in radians. Let me convert it into degrees. Okay, now sine 0 is 0, sine 90 is 1, and sine of 180, this is also 0, y equals to 0. All right, so sine 0, this is 0, sine 90, so this is 0 to 150, so there is 90 lying between 150, so closer to 150 we have a 90. So let's say 90 is over here. So at 90, its value is 1. So this is 2, and below this 2, we have 1. Let's say 1 is over here. All right. And y is 1. And for 180, 150, and let's say we have 180 over here. So at 180, its value is again 0. All right, and then 180, let me take 180 plus 90 is 270. Sine of 270 is again negative, it's -1. Yes, let's say we have 270 over here. Sine of 270, we have a -1 downward. Let me draw this curve. Okay, now let me sketch the parent function. From 0 we have 1, at 90 it is 1, and then we have again 0 at 180, and then we have a -1 at 270, and then so on. So this is my base function. This is a sketch of my base function. So from the base function and the given, the transformed function, we have to first find the value of alpha. As we know that alpha is the phase shift, or we can say the starting point of the curve. This is a phase shift. All right, so as you can see, the base function is, its value is 0 at 0 and at 180, right? But the transformed function, its value is 0, the first value 0 at 150, and then some other point. All right, okay, so we have to find the difference. Basically that would be the phase shift between, so 180 and 150, that would be the phase shift. So we can say the value of alpha is phase shift between 180 minus 150, which is equals to 30 degree. All right, so we have alpha, which is equals to 30. Let me explain it one more time. In these type of questions, when you have given the transformed sinusoidal function, and we have to calculate the missing transformations. So first, the main thing is we have to okay, let me explain you the phase shift one more time. So whenever you have given these types of transformed sinusoidal functions, so the first step you have to do is to draw the graph of the base function. The base function, I did just like I drew the graph of the base function, and then you have to find out the transformations. As you can see, k is my amplitude and alpha is my phase shift. Phase shift is basically the starting point of the curve. All right, so as you can see, this curve starts from 0 and the other x-intercept is 180. So the base function starting with 0, so it has no phase shift. That alpha value is 0 in the base function. But this functions starting the first x-intercept is starting with 2 and the first x-intercept is at 150. It moving downward. So if we can compare this a transformed function from 150, it moving downward, so at 180 it is also moving downward. So between 180 and 150 we have to do the subtraction and find out the difference between them to get the phase shift. All right, I hope this is clear now. Now moving to the value of k. So to get the value of k, let me use this information that the y-intercept is 2. The y-intercept So y-intercept is 2. So what is the y-intercept? Which is 0, 2. The x should be 0, means the theta is 0 and the y is equals to 2. So plug this into the equation. We can say y equals to k sine theta plus alpha, which is 30 degree. Now theta is 0, y is 2. 2 equals to k sine 0 plus 30 degrees. So this is sine 30 basically. So 2 equals to k into sine of 30. So 2 divided by sine 30, that is the k value. Right, so what is sine of 30? 1 by 2, and 2 divide answer, this is just 4. So 4 is the k value. All right, so we can say the value of k is 4 and the value of alpha, the phase shift, is 30 degrees. Question number 6, the diagram shows a sector POQ. PO and Q. Yes, this is a sector. Okay, of a circle of radius 10 centimeter and center is O. Okay, POQ is the sector of a circle and the radius is 10 centimeter. O to P is 10 centimeter. O to Q is also 10 centimeter. The center is O. Angle POQ. POQ is 2.2 radians. QR is an arc. Q to R, this is an arc of a circle with the center P. Now this is an arc of another circle and the center of that circle is P. And POR is a straight line, POR. Alright, number 1, show that the length of PQ. The length of PQ is 17.8 centimeter, correct to 3 significant figures. Alright, so we have to calculate the length of PQ. P to Q. Alright. So if I consider this triangle POQ, we have PO, we have OQ, and we have the angle. So we have to find its front side. So let me apply law of cosine. Law of cosine on triangle POQ. Alright. So PQ, its square, equals to the two sides 10 and 10 square minus 2 into 10 into 10, and cos of the angle between them is 2.2 radians. Alright, now let me calculate PQ. My calculator is in degrees, convert it into radians. Okay, cos of 2.2 and times by 10 times by 10 times by minus 2. Alright, plus 10 square plus 10 square, that is PQ square is 317.700. Alright, so from here we can solve PQ, which is a square root of 317.70. Alright, so square root of answer, which is 17.82. Okay, so PQ is 17.824. We have to find the answer up to 3 significant figures. 1, 7 and 8 are the 3 significant figure, and the next digit is 2, so we have to round down, so keep it as it is. So PQ up to 3 significant figure is 17.8 centimeter. So this length is 17.8. All right. Now for the second part, find the parameter of the shaded region. Alright, so this is a shaded region, O, R, Q. This is the shaded region. We have to find its parameter, means we have to find OR, we have OQ which is 10, and we have to find QR as well. Alright, so how can we get QR? As we know that QR is an arc of a circle with the center P. P is the center and QR is the arc. Alright, so we have to find the arc length of this circle, but for arc length we have to find the radius and theta, radius times theta. So radius we have is PQ is the radius, PR is the radius. If PQ is 17.8, PR is also 17.8. So P to R, this length, this PR is also 17.8. because this is the circle with the center P, PRQ and PR. Okay, if this is 10, so what is OR? Okay, 17.8 subtract 10, this is 7.8. So we got OR which is 7.8, OQ is 10. Let me solve this arc length. radius times theta. So we have the radius, but we don't have theta. All right, how can we get the value of theta? If I consider this triangle again, PQ and POQ, all right, we have all the three sides and one angle. So applying law of sine to get that angle. This angle and the front side, this angle and the front side. Okay, applying law of sine. Law of sine on triangle P, O and Q. All right, so we have to solve for angle P. Let me name this angle P. Sine P over the front side is 10. So here we can say sine P over its front side is 10. This is equals to sine of 2.2 radians over its front side is 17.8, which is PQ. Sine of 2.2 over 17.8. All right, so let me solve for sine P. So from here, sine P is going to be 10 over 17.8 cross multiplication, multiply by sine of 2.2. And P is going to be sine inverse of that answer. Okay, let me calculate it. It should be in radians. Okay, sine 2.2 and times by 10 and dividing by 17.8. All right, 0.4542. 0.4542. Sine inverse of answer. This is 0.47. So we can say angle P is equals to 0.47 radians. All right. Let me label this on the diagram. 0.47 is that angle. Now if I consider the arc length of the sector of a circle P, R and Q, this is a sector of another circle with the center P, and calculating the arc length. Okay, so arc length RQ, this is equals to radius times theta. Radius is 17.8 and theta is 0.47 radians. Okay, that is a theta, and times it by 17.8, that is 8.39. This is 8.39, we can say 8.4 centimeter. All right, so this is 8.4. This is 0. Now the parameter of the shaded region is OR, which is 7.8. R to Q is 8.4 and OQ is 10. Add them up, we will get the parameter of the shaded region. All right, parameter of shaded region. So that is a sum of OR, OQ and QR. OR is 7.8, OQ is 10 and QR is 8.4. All right, 10 plus 8.4 plus 7.8, that is 26.2. 26.2 centimeter is the parameter of the shaded region. Question number 7. Figure 1 shows a rectangle with a sides 7 units and 3 units. This is a rectangle and the sides are 7 units and 3 units, 3 units, from which a triangular corner has been removed. This is the triangular corner which has been removed, leaving a 5-sided polygon. Now this is a 5-sided polygon, 1, 2, 3, 4, 5. OA, B, C, D. The sides OA, AB, BC and OD have length 7 units, all right, 3 units, 3 units and 2 units respectively. Figure 2 shows the polygon OABCD forming the horizontal base of a pyramid. Okay, this would be the base of the pyramid, in which the point E is 8 units vertically above D. this is the point E, which is 8 units vertically above D. All right. And unit vectors I, J, and K are parallel to OA. I is parallel to OA. J is parallel to OD, and K is parallel to DE, vertically above, because it is, all right, respectively. Number 1, find CE and the length of CE. Okay, so first we have to find the vector CE, and the length of CE, basically the magnitude of CE. Okay, so C to E, we have to follow the path because this is in 3 dimensions, I, J, K. So C to E, first we have to move C to this point in terms of in the direction of I, then this point to D in the direction of J, and then this point to E in the direction of K. All right, so I, J, and K, the 3-dimensional vector. All right, so let me draw the path which we are moving from C to E. So from C to this point we are moving in this direction, right? So this is OA, or this point, these are in the direction of I, so this is a negative I. All right, and then in moving downward, this is J, so we are moving down, so this is negative of J, and the upward, this is in the direction of K, positive K. All right, I hope this is clear now. So first from C to E, first we have to move C to this point, then to D, and then to E, because we are in 3-dimensional space, so we have to cover all 3 I, J, K vectors. Okay, so from C to this is 4, so we have negative 4I. So let me write this down first. Let's say this is X, I can label it. So from C to E, in terms of I, J, K, we have to move C to X first, and then from X to D, and then from D to E. All right, so C to X is in negative of I. This is I, and this is negative of I, and this from the first figure we know that this is 4 units, so minus 4I we can say. All right, now X to D, this is in the direction of J and negative J, and this is 1, so negative 1J, and D to E in the direction of K, and this is 8 units, so plus 8K. All right, so here we can say that CE vector is minus 4I minus J plus 8K. This is a vector of CE, and now let me find out the length of CE. Length of CE is going to be square root of I component square plus J component square plus K component square. All right, let me simplify. This is square root. We have 16 plus 1 plus 64. Simplify, we have 16 plus 1 plus 64, square root of 81, which is 9. And 81 is 9 units. We can say is the length of CE. Now for the second part, use a scalar product. Scalar product is the dot product to find the angle CECA. Okay, which angle is ECA? ECA, this angle. All right, and giving your answer in the form of cos inverse of m over root n, where m and n are integers. Okay, so the scalar product is basically the dot product. Let me write down the formula of the dot product, which is equals to, if I can say, A and B are the 2 vectors, so A dot B is the magnitude of A, magnitude of B, and cos of theta, the angle between them. Now what is A and B in this case? So this angle we have to calculate. So we have CA, CE, dot product of CA and CE we have to calculate. So we have CE, which we got in the first part. Okay, so let me write down CE. CE is minus 4i minus j plus 8k, right? And we have the magnitude of CE as well, which is 9. All right, now we have to find what is CA. C to A, which path we have to follow. So we have to move from C to A in this direction. So first we have to cover C to X. C to X, X to O, and then O to A. Okay, let me find out CA over here. C to A is C to X. This is 4 minus 4i. X to O, this length is 3, so minus 3j. And O to A, this length is 7 and minus 7i. Okay, let me solve minus 7i and minus 4i, that is minus 11i and minus 3j. This is my CA. Let me write this down. CA is minus 11i and minus 3j. Now let me find the magnitude of CA, which is square root of minus 11 square plus minus 3 square. Alright, so 11 square plus 3 square is 9 and square root of 130 is 11.4. Alright, so now applying the formula for the dot product, we can say the scalar product or the dot product is going to be the dot product of CA and CE. This is the magnitude of CA, magnitude of CE, and cos of theta. What is theta? Theta is the angle ECA. This is theta. All right, so we have the two vectors. Let me do the write down. CA and CE, which is minus 11i minus 3j and plus 0k. Its dot product with minus 4i minus j plus 8k. This is equals to the magnitudes are 9 and 11.4 and cos of theta. I'm really sorry, I did the blender over here. So I just checked that we have OA, this in the direction of I, so this is plus 7. So from 7 take away 4, this would be 3i. So this vector is 3i minus 3j. I'm really sorry, I messed up. So this would be 3. All right, so this is 3 square plus 3 square is going to be 9 plus 9 is 18 and square root of 18 is 3 root 2. All right, so CA dot CE, magnitude of CA, magnitude of CE, and cos of theta. All right, so dot product I component is product with I. 3 times minus 4 is minus 12 plus minus 3 times minus 1 is 3 and plus 0 times 8 is 0. All right, now we have 9 times 3 times root 2, 27 root 2, 27 root 2 cos of theta. All right, and 3 minus 12 is minus 9. Minus 9 equals to 27 root 2 cos theta. What is cos of theta? So minus 9 divides 27 root 2. So dividing by 27 root 2 on both sides to get cos theta. Divides 27 root 2. This is minus root 2 over 6. But I'm not writing in this form because we have to find the answer in cos inverse of m over root n. Root should be in the denominator, m and n both are integers. Alright. So just let me simplify. What is 9 over 27, which is 1 by 3. So this is cos theta equals to minus 1 over 3 root 2. Okay. Now we can rewrite as cos theta is equals to minus 1 and 3 root 2. This is 3 root 2 and this is equals to 9 plus 9 equals to 18. Root 18 is 3 root 2. Root of 18 is 3 root 2. Yes, we can write this as root of 18. So this is in the form of m over root n. M is minus 1, which is an integer, and n is also an integer, which is 18. So we can say theta is going to be cos inverse of minus 1 over root 18. This theta is the angle ECA. Question number 8. A curve has equation y equals to this. Number 1, find the x coordinate of the stationary point. Stationary point, it means we have to put y prime equals to 0 and solve for the x coordinate, right? So first we have to calculate y prime, dy over dx. We have y, we have to find out the derivative. So 1 by 2 is as it is, derivative of x squared is 2x. Minus 4 is as it is, its derivative is, first write down the power, the base function, power minus 1, so 3 by 2 minus 1, and plus 8 is as it is, derivative of x is 1. 3 by 2 minus 1 is 1 by 2. So here let me simplify. 2 is cancelled with 2, so we are just left with x. And we have 2 times 1 is 2, 2 times 2 is 4, 2 times 3 would be 6, minus 6, x to the power 1 by 2 and plus 8. This is the derivative, right? Now for stationary point, we have to put the first derivative equals to 0 and solve for x. That would be the x coordinate. Alright, so dy over dx, this is going to be 0. So the first derivative is x minus 6, x to the power 1 by 2 plus 8 equals to 0. So if we closely observe, this is a quadratic equation in x. Because if I can write, the quadratic equation is in the form of ax square plus bx plus c equals to 0. We have a constant c. We have x and x square. Means the first power is 2, the second is 1, and the third is 0. So here the first power is 1, the second is half, and the third is 0. Right? So we have a quadratic equation in x. So to solve this, we use x equals to, by using the quadratic formula, we did x equals to minus b plus minus square root. This is x equals to minus b plus minus root b square minus 4ac divides 2a. This is a quadratic formula we apply to get the value of x, the second coefficient. Now we have to use to get the value of x power 1 by 2. I hope this makes sense now. Now let me apply the quadratic formula to get x to the power 1 by 2, which is negative of b plus minus root b square minus 4a and c divides 2 into a is 1. Alright, now we have x to the power 1 by 2. This is going to be 6. Now we have 4 times 8 is 32, and 6 square would be 36 minus 32, and root of 4 is 2. So plus minus 2 divided by 2. So we have two solutions. So x to the power 1 by 2 is 6 plus 2 over 2. And x to the power 1 by 2 is 6 minus 2 over 2. 6 plus 2 is 8, and 8 dividing by 2 is 4. 6 plus 2 dividing by 2, this is 4. X to the power 1 by 2 is 4. And we have 6 minus 2 divided by 2, this is 2. This is going to be 2. Now this is x to the power 1 by 2, but we have to find the x coordinates, just the x value. So how can we get the x value? If we are doing squaring on both sides, we will get the x value. So from here we will get square root of x, and it's square just cancel out. We have x equals to 16, and here x equals to 4. So these are the two x coordinates of the stationary points. Now for the second part, find d2y over dx square, the second derivative. So d2y over dx square, this means we have to find d by dx of the first derivative, which is x minus 6 x to the power 1 by 2 plus 8. Alright, so x derivative is 1, minus 6 is as it is, this derivative is power base and power minus 1, and 8 derivative is, this is constant, so its derivative is 0. Alright, so 2 times 1 is 2, 2 times 3 would be 6, so 1 minus 3 x to the power minus 1 by 2, this would be the second derivative. Now for part C, find showing all necessary working to the nature of each stationary point. The nature of the stationary point, we have two stationary points, x equals to 16 and x is equals to 4, which we got from the first part. 16 and the 4 are the two stationary points, right? We have to find out the nature, so we have to plug these 2 points one by one into the second derivative and check the nature. So we can find d2y over dx square at x is equals to 16. So we have 1 minus 3, 16, power is minus 1 by 2. Let me simplify this. 16 power is minus 1 by 2, and times minus 3 and add 1. This is 1 by 4. So it's 1 by 4. It is positive, greater than 0. So when the second derivative is positive, it means this is the minimum stationary point. X equals to 16 is the minimum stationary point. Now let me check the second one, d2y over dx square, the second derivative at x equals to 4, the second stationary point. Now this is 1 minus 3, 4 to the power minus 1 by 2. Let me calculate 4 to the power minus 1 by 2 times by negative 3 and add 1. This is minus 1 by 2. So this is less than 0. When second derivative is negative, it means that stationary point is maximum. Alright, so the stationary point 16 is a minimum and 4 is the maximum. Question number 9. A curve has equation y equals to 1 by x plus c, and a line has an equation y equals to cx minus 3, where c is a constant. Number 1, find the set of values of c for which the curve and the line meet. Okay, so the curve and the line meet, so it means we can say 1 over x plus c, this should be equals to cx minus 3. The curve and the line, it meets. Now let me simplify. We can say 1 plus cx over x is cx minus 3. I did the LCM in this step, so make the same denominators. Now cross multiplication, 1 plus cx is as it is, and x is multiplying with cx minus 3. Now 1 plus cx equals to cx square and minus 3x. Now shifting all the terms to the right side, so we have cx square minus 3x, and this is minus cx minus 1 equals to 0. Cx square minus x, and we have 3 plus c and minus 1, this is equals to 0. Alright, so we have a quadratic equation. All right, so we have to solve the discriminant because we have to find the set of values of C when the curve and the line meet. So the curve and the line meet, it means the discriminant should be equals to 0 when it has one solution, and it is greater than 0 when it has more than one solution. When discriminant is less than 0, it has no solution. The curve and line does not meet. So it means we have to solve b square minus 4ac should be greater than equals to 0. Equals to 0 means one solution, and greater than 0 means two solutions, more than one solution. All right, so what is b? B is minus 3 plus c, this whole square, minus 4 times ac, and the c value is minus 1. This is greater than equals to 0. So opening the square, minus square is just positive, so we have 3 squared is 9 c square, and plus 2ab. 2 times 3 would be 6c, and this is 4c. This should be greater than equals to 0. All right, so c square plus 10c plus 9 is greater than equals to 0. Right, so let me apply the quadratic equation. So we have we have 1 times 9 is 9, and 1 plus 9 would be 10. C square plus c plus 9c plus 9. I'm factorizing. C is common, c plus 1 is left, plus 9 is common, c plus 1 is left. This is greater than equals to 0. C plus 1 is the factor and c plus 9 is the factor. This is greater than equals to 0. So we can say c plus 1 is greater than equals to 0, and c plus 9 is greater than equals to 0. So c is greater than equals to minus 1. Okay, so first I'm just solving for zeros, putting them equals to 0, sorry. So for the zeros, we can say c plus 1 equals to 0, so c equals to minus 1, and c plus 9 equals to 0, so c equals to minus 9. All right. Now let me visualize this situation. If I can draw the two roots over here. Let me use the pen. It should be on the negative side. We have two roots, minus 1 and minus 9. Okay, so this is a quadratic equation, and this is the parabola, and the opening of parabola is upward because c square coefficient is positive. This would be the opening of parabola. All right, so we have two roots. The first root is minus 1 and the other is minus 9. All right, now we have to find the solution when these two are greater than and equals to 0. These two are equals to 0, and greater means the upper portion, right? So we can write down the inequality. From here we can say for this upper portion means the c is less than equals to 9, and c is greater than equals to 1. Let me explain one more time. So we are working on solution when these two are greater than, because we have a quadratic equation. This is a quadratic equation, and this should be greater than equals to 0. So this is a sketch of this quadratic equation, and the roots of this quadratic equations are minus 1 and minus 9, which I already plotted. So it's a parabola, is opening is upward because c square coefficient is positive, right? Now we have to find the solution when it is equals to 0 at minus 1 and minus 9, and when it is more than 0. So when the x values are less than minus 9, because minus 10, minus 11, minus 12 are less, right? When x values are less than minus 9 and when x values are more than minus 1, it is extending, right? So we have two solutions when c is less than equals to minus 9 and c is greater than equals to minus 1. These are the two set of values of c where the line and the curve meet. Now for the second part, the line is tangent to the curve for two particular values of c. When the line is tangent to the curve, it means tangent means touch at one point. because tangent always touch at one point, not more than one point. So the line is tangent to the curve, means line touch the curve at exactly one point for two particular values of c. So this is obvious that the discriminant is equals to 0. So the two values are -1 and -9, right? For each of these values, find the x coordinate of the point at which the tangent touches the curve. The x coordinate we have to find, all right? So this is the line touch the curve, all right, and we got this equation. So let me rewrite. So cx square minus 3 plus c x minus 1, this is equals to 0. Now at c equals to -1, so here we have -1 x square minus 3 minus 1 into x minus 1 equals to 0. So this is minus x minus 2x minus 1 equals to 0. Taking negative sign common, we are left with x square plus 2x plus 1 equals to 0, and that is the formula of x plus 1 whole square. We can say x plus 1 whole square equals to 0, or x plus 1 equals to 0. From here x is equals to -1. This is the x coordinate of the point at which the tangent touches the curve. That is the first x coordinate, right? Now for the second one, at c is equals to -9. Let me substitute c equals to -9 x square minus 3 minus 9 into x minus 1 equals to 0. This is -9x square. From 3 take away 9 is -6, and then -6 and -6 would be plus 6x minus 1 equals to 0. Taking negative sign common, 9x square minus 6x plus 1 equals to 0. So this would be 9x square minus 6x plus 1 equals to 0. All right, 3x whole square minus 2 into 3 into x plus 1 square equals to 0. So I just write down the formula of a square minus 2ab and b square, right? Sorry, this is 3x and b is 1 over here. So this is 3x minus 1 whole square. That is the formula. Or we can say 3x minus 1 equals to 0. So from here x would be equals to 1 over 3. This is the second x coordinate of the point where the tangent touches the curve. Question number 10. Functions f and g are defined by, we have f of x and g of x, both are the same functions, but the domain is x is greater than 2, and here x is between 2 and 4. Now for number 1a, state the range of the function f. Okay, the domain of the function f we have given x greater than 2. All the values of x that are more than 2, like 3, 4, 5, 6, 7 up to positive infinity. So if I can say let x is equals to 3, let me check at x equals to 3. What is f of 3? F of 3 is equals to, let me simplify, we have 8 divides 3 minus 2 and plus 2. This is 10. Okay, now let x is equals to 4. What is f of 4? All right, so 8 divides 4 minus 2 and plus 2. That is 6. Okay, now let x is equals to 5. We have f of 5. That is 8 divides 5 minus 2 plus 2, 4.6. Oh, okay, so we have checked at x equals to 3, 4, 5, because the domain we have given is x values that are more than 2. So more than 2 is 3, 4, 5. So the outputs are 10, 6, 4.6. We are not getting any answer for the range. So let me check, because more than 2 if I can take at let me take at 10. So 8 divides 10 minus 2 and plus 2, so that is 3. Now let me take at 20. So 8 divides 20 minus 2 and plus 2, 2.4. Let me take at 30. 8 divides 30 minus 2 and plus 2. This is 2.2. So as you can see, for 10 we get 3, and then for 20 2.6, for 30 2.2. So all the values we can, if I can say up to so on, if x is 10, x is, let's say, 20, and x is, let me check at 50 as well. For x is 10, we got f of 10, I guess 8 divides 10 minus 2 and plus 2, we got 3. Okay, 8 divides 20 minus 2 and plus 2, which is 2.4. F of 20 is 2.4. Let me check at 50. 8 divides 50 minus 2 plus 2, 2.1. F of 50, that is 2.1. F of 100, 8 divides 100, take away 2 and then add 2, that is 2.08. Means all the values, if I can take x equals to 100 as well, so f of 100 is 2.08, which is 2.1 again. So as you can see the outputs, now we got the results that the output is greater than 2. 10, 6, 4.6, then we got 3, and it's closer to 2. Now we can easily guess for 20, x when x is 20, 50, 100, so it is closer to 2. So it means the range of f of x is greater than 2. All the out means the output is more than 2. So range is basically the output. Now moving to part B, state the range of the function g. All right, so for the function g, this is the function. So for as you can see, the domain is between 2 to 4. All right, so 2 to 4 we have a number 3, and let me check at 2.5, 3 and 3.5. all right, let x is 2.5, x is 3, and x is 3.5. We can easily guess what is the range. So g of 2.5 and g of 3 and g of 3.5, we have the same function. All right, so 8 divides 2.5 minus 2 and plus 2, that is 18. All right, let me check at 3. 8 divides 3 minus 2 and plus 2, that is 10. Okay, 8 divides 3.5 minus 2 and plus 2, that is 7.3. okay, now move closer to 4. Let's say x is equals to 3.9. what is f of 3.9? okay, 8 divides 3.9 and minus 2 and plus 2, that is 6.2. so the values are 18 and then 10, then 7.3, and then 6.2. the values are approaching to 6, so we can easily guess that output is, we can say the range of g of x is greater than 6. Right, now for part C, state the range of the function f composition g. Okay, so in this question, first we have to check, is the composition possible? So the composition f composition g is possible if the range of inner function, the range of g of x that is more than 2 lies inside the domain of outer function. Outer function is f of x and its domain is x is greater than 2. All right, so as you can see, here f composition g is possible because the domain of g, the range of the inner function, that is more than 6, all the values that are more than 6, and this lies inside the domain of the outer function that is more than 2. So more than 2 values cover more than 6, right? So we can easily guess the range of the composite function from here. So the range of composite function is between 2 to 4. 2 is less than f of g is less than 4. All right, now for the second part, explain why the function g composition f cannot be formed. Okay, so we can say gf cannot be formed because the range of inner function, the range of f of x, what is the range of f of x, which is more than 2, does not lies inside the domain of outer function, the domain of g of x, and the domain of g of x we have is 2 is less than x is less than 4. That is why g composition f cannot be formed, because the range of the inner function, the inner function is f and its range is all the values that are more than 2, and more than 2 values means from 2 to infinity, means basically from 3 to positive infinity. We can take these values does not lies inside the range domain of the outer function. This is between 2 to 4, but we have we have 2 to 4, but we have here 2 to infinity. So this is the only reason we cannot form g composition f. Now for part 3, find the set of values of x satisfying the inequality. All right, so in this inequality we need f prime of x and f inverse of x. So first let me solve for f prime of x. We have f of x, which is equals to 8 over x minus 2 plus 2. Let me solve for f prime of x. F prime of x, this is going to be 8 is as it is, and we have here the power is, if I can rewrite this, 8 x minus 2, its power is minus 1 and plus 2. Now applying the power rule, first we have a power, then the base function, then we have power minus 1, and the derivative of base function is just 1. This derivative is 1, this is 0, and the derivative of constant is also 0. So that is negative 8 over x minus 2, its whole square. We have minus 2 power, so I shift it into the denominator. That is f prime of x. Now let me solve for f inverse of x. Okay, now for inverse, what we have to do, so first thing is we have to put y equals to f of x, y equals to f of x, and then we have to switch the variables. We can say x equals to 8 over y minus 2 and then plus 2. Now we have to solve for y. So we have x, shifting this 2 on the other side, minus 2, this is equals to 8 over y minus 2. Now cross multiplication, we have y minus 2 is over here and 8 over x minus 2 in the denominator. Now y is going to be 8 over x minus 2 and plus 2, shifting the 2 on the other side and solving for y, and this y is my f inverse of x. All right, now let me solve the inequality. Rewrite the inequality, which is 6 f prime of x plus 2 f inverse of x minus 5 is less than 0. So 6, what is f prime of x? We have minus 8 over x minus 2 square plus 2. F inverse of x is 8 over x minus 2 plus 2, and negative 5. This is less than 0. Let me simplify. So we have 6 times negative 8 minus 48 x minus 2 whole square plus 2 times 8 is 16 over x minus 2 plus 2 times 2 is 4 and minus 5. This is less than 0. So in these two fractions, let me make the same denominator, or let me do one more step. 48 over x minus 2 whole square plus 16 over x minus 2 and minus 1 is less than 0. Alright, now let me make the same denominators. So taking the LCM, minus 48 is as it is. We have to pick the bigger one. Alright, and plus 16 is multiplying with x minus 2 and minus is multiplying with x minus 2 whole square. X minus 2 whole square, that is the LCM. This is less than 0. Further simplification, minus 48 plus 16x minus 2 times of 16 is 32 minus x square minus 2ab, that was 4x and plus 4 less than 0, and x minus 2 whole square, it is divided by, let me open the bracket, minus 48 plus 16x minus 32 minus x square plus 4x minus 4, and this term multiplying with 0 is just 0, cross multiplication. So we have negative of x square, the x terms are 16 and 4, so that is 20 x, and the constants are minus 48, minus 32 and minus 4. Okay, 48 plus 32 plus 4 minus 84, that is less than 0. So as you can see, this is a quadratic equation, x square, right? And the leading coefficient is negative. It means the opening of the parabola is downward. All right, let me find out the roots. So to find out the roots, we have to put the equations minus x square plus 2x, 20x minus 84 equals to 0. All right, and let me factorize this. Okay, minus 1 times minus 84 is 84. We have to find the factors of 84. When we add them, that would be 20. Okay, so let me check. 84 divides 2. 2 times 42 is 84, but 2 adding is not 20. 84 divided by 3. 28 and 3, not 20. 84 divided by 4. 21 and 4, add and subtract not makes 20. 84 divided by 6. 6 times 14 is 84. Yes, 6 times of 14 is 84, and 6 plus 14, that is 20. We can break the midterms. Minus x square plus 6x plus 14x minus 84, that is equals to 0. Taking negative and x common, we are left with x plus 6. Taking positive 14 common, because 84 divided by 14 is 6. We have x plus 6, x minus 6, sorry. We took negative sign common, so it is minus over here. This is equals to 0. So the factors are x minus 6 and 14 minus x equals to 0. Alright, put both factors separately equals to 0 and solving for x. So from here, x minus 6 equals to 0, x is equals to 6, 14 minus x equals to 0, and x is equals to 14. We have two factors, 6 and 14. Now this is a quadratic equation. Alright, and the leading coefficient is negative. It means the opening of the parabola is downward, and we have two factors, which is 6 and 14. So let me check. Let me draw this first. So 6 and 14. Both are positive. This is the shape of the parabola, let's see. let's say this is 6 and this is 14. All right. Okay, the two roots are 6 and 14, and the parabola opening is downward, and we have to find the inequality when this is less than 0. So it is less than 0 when x is, the values of x are less than 6 and the value of x is more than 14. Now this is one set of values of x that satisfy the inequality. We have another one, let me show you. So we have done with the numerator. So I put the numerator less than 0. As you can see, the numerator is less than 0. I simplified and I got the two solutions, like x is less than 6 and x is more than 14. This is greater than 14. Less than 6 and greater than 14, the values are less. Okay, there is another solution. As you can see, the denominator is, we have to put this. Let me show you how can we do. So we can say 1 out of x minus 2 whole square is less than 0. The denominator I'm solving over here. All right, the reciprocal x minus 2 whole square is greater than 0. So whenever we are doing a reciprocal, we have to change the inequality sign from less to greater. Now we have to do square roots on both sides. So taking square roots of 0 is just 0. So we have x minus 2 is greater than 0, and from here x is greater than 2. All right, now we have to check the solution. Okay, let me draw the number line and show you guys about the solution. Okay, let's see, this is the number line. Okay, 2, 6 and 14 we have. If I can start from 0 over here, 0, 2, 4, 6, 8, 10, 12, 14 and so on. All right, now the first is x is greater than 2, the values that are more than 2. So from 2, the more than 2. From this point, and this is more than 2. All right, now x is less than 6. Here we have 6. The values that are less than 6 are these values, are less than 6 over here. And x is more than 14. Here is 14. And greater than 14 are these values. How can we make the inequalities now? As you can see, we have the values more than 2 and less than 6. So it is between 2 and 6 and more than 14. So we can say 2 is less than x is less than 6 and x is greater than 14. So these are the set of values of x that satisfy the inequality, and that is the inequality. Right. Question number 11, the diagram shows part of the curve y equals to the part of this curve intersecting the x-axis at origin 0, 0 and at point A, which is 1 by 2 and 0. The line AB intersect the y-axis at B. So it intersect the y-axis, it means the x component is 0, there is some y component, and has an equation y equals to 1 minus 2x, and it has an equation. All right, now for the first part, show that AB is tangent to the curve at point A. We have to show that the line AB, this is tangent to the curve at point A. So basically we have to find the equation of tangent. So the equation of tangent at point A. All right, so the equation of tangent is y minus y naught equals to m at the point A into x minus x naught. Okay, what is x naught and y naught? We have x naught and y naught is the point A, which is 1 by 2 and 0. And what is m? M is the slope of this line. Let me solve for m. So m is basically dy over dx. It means we have to calculate d by dx of 1 minus 2x. The derivative of 1 is 0. The derivative of minus 2x is just minus 2. Right? Let me plug into the equation of tangent. We have y minus y naught is 0 equals to m is negative 2, x is 1 by 2. Sorry, we have x minus x naught, and x naught is minus y is 1 by 2. Alright, so we have y equals to negative 2 into x minus 1 by 2. Y equals to minus 2x and plus 2 into 1 by 2. So 2 is cancelled out with 2. We have y equals to negative 2x plus 1. Or we can say y equals to 1 minus 2x. So this is proved. We have shown that AB is tangent to the curve at point A. The line AB, this is tangent to the curve at point A. It is tangent because they have the same slopes. The slope of this line is negative 2 and the slope of equation of tangent is also negative 2. Now for the second part, show that the area of the shaded region can be expressed as this. Alright. Let me show you the area of the shaded region. This is a shaded region. To calculate the area, we have to find the area of area under this line and subtract area under the curve, right? Because first we have a line and then we have a curve, because the under the curve it is not shaded, above the curve it is shaded. So area under the line we have to do from 0 to half, and area minus area under the curve, because under the curve is not shaded. So let me write this down. So we can say area is going to be area of a line minus area of curve. So area of a line is between 0 to 1 by 2, 0 to half, and the line we have is 1 minus 2x dx, minus the curve is also from 0 to half, and the equation of curve is 1 minus 2x minus 1 minus 2x whole cube into dx. Now we have 0 to 1 by 2, 1 minus 2x dx, and minus 0 to 1 by 2, 1 minus 2x dx. I just split this term 1 minus 2x and this term with negative times negative is positive, and 0 to half 1 minus 2x whole cube dx. Now you guys can see we have a positive and a negative integral with the same limits and with the same integrand. We can cancel them out and we have then area 1 over half, 1 to half, sorry 0 to 1 by 2, 1 minus 2x its whole cube dx. So that is the area of the shaded region. Now for this third part, hence show all necessary working, find the area of the shaded region. Alright, so to calculate the area of the shaded region, for this basically we have to solve the integral. So for integration of this we have to complete its derivative. The derivative is negative 2. Alright, so what we have to do, we have to multiply and divide by negative 2. Minus 1 by 2 is outside, 0 to 1 by 2, minus 2 is inside, 1 minus 2x cube and dx. Now the derivative of this function is negative 2 and it is with that function, so we can easily integrate it. So minus 1 by 2 is outside, this is 1 minus 2x, its power is 4 over 3 plus 1 is 4, plus some constant of integration we are not using because we have a definite integral. Alright, let me simplify this. Minus 1 over 2 times 4 is 8, 1 minus 2x power 4, and the limit 0 to 1 by 2. Let me plug the limits. Minus 1 by 8, 1 minus 2 into 1 by 2, its power is 4, minus the lower limit, upper limit. I plug the upper limit in this function, which is 1 by 2. Now subtract the lower limit. So this subtract and this subtract would be plus 1 by 8. The lower limit is 0. 1 minus 2 into 0 its power is 4. So 2 is cancelled with 2, plus 1 and minus 1, this term goes to 0. And we are left with 1 over 8 into 1 power 4. So that is just 1 by 8. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.